Good day, learners! Welcome to Math Corner's General Mathematics for Senior High School, Episode 8, entitled, How to Determine the Domain and the Range of a Function. In my previous video, I already enumerated the 9 basic functions and its corresponding graph, domain, and ranges. Now for today's video, I'm gonna explain few examples about how to determine the domain and the range of a particular function. Let's take a look with this example. Given the function f of x is equal to 5, as what you can observe, the given function is a constant function. Now, as we all know, that the domain of the constant function is a set of all real numbers. Therefore, it starts with negative infinity to positive infinity. And the range of our constant function is the constant itself. But how does the graph of the constant function look like? Before we are going to proceed in graphing, we are going to complete first the values in our table of values. As I said, the domain of our constant function is the set of all real numbers. Therefore, we can take any number as the values of our x. For example, I will take negative 3 until positive 3 as our input or as our domain. And then, how are we going to determine the values of our f of x or our y? Our y or our range. Now, as we all know, that no matter what the values of our domains are, still our range will be the constant itself. So for example, our domain is negative 3, our range is still positive 5. If our domain is negative 2, it's still positive 5. It follows 5, 5, 5, and 5. Now, as what you can observe, as I said, that no matter what the values of our domains are, the range are still the constant itself. So the range here will be the interval 5 to 5. Okay. Let us proceed now in plotting these points to this Cartesian plane. So for example, we have here negative 3 and positive 5. So negative 3 and positive 5 will be right here. Negative 2 and 5 will be right here. Negative 1 and 5. 0 and 5. 1 and 5. 2 and 5. And 3 and 5. Now, as what you can observe, this is the graph of our constant function. As what you can observe, the graph of the constant function does not take any other values in our y-axis except the constant 5. And our graph can be extended on both sides to negative infinity and to positive infinity. Let's take a look with this example. Given the function f of x is equal to 5 minus 2x squared, now this is an example of a quadratic function. As we all know, that the domain of a quadratic function takes the set of all real numbers. That means it starts from positive infinity to negative infinity. But how about the range? Now, before we can identify the range of the given function, we will first graph the given function, and then after we graph, we will identify what will be the range of this given function. So first, we are going to complete first the table of values. As I said, because the domain is the set of all real numbers, we can take any number here. So I will take negative 3, negative 2, negative 1 until positive 3. Now, what's next after here? We are going to substitute each of the values of x to our given function. So for example, we are going to substitute negative 3 to our given function. That will be 5 minus 2 times negative 3 squared. That will be positive 9. So negative 2 times positive 9, that will be negative 18. And 5 minus 18, that will be negative 13. And if we are going to continue the process by substituting all the values of x to our given function, it yields to these following values. We have negative 3, positive 3, 5, 3, negative 3, and negative 13. Since we already completed the values of in our table of values, we can now proceed to graphing or plotting these points in our Cartesian plane. So we will start from the ordered pair 0 and 5. So that will be 0 for x and 5 for y. And then we have here negative 1 and positive 3. Negative 1, positive 3 will be here. Positive 1 and positive 3, that will be here. And then we have here negative 2 and negative 3. Negative 2, negative 3, the point will be here. And then positive 2 and negative 3, the point will be here. Now, using the following points here, we can now identify the graph of the given function. So we can connect the points from here. And the same here, we are going to connect the points going downward. As we all know, the graph of the quadratic function is a parabola. So here, this is a parabola going downward. So what's next after here? We can now identify the range of our given function. Since we will identify the range of the given function, we will focus only on the y-axis. As what you can observe, the highest value in the y-axis is only positive 5. There are no other values greater than positive 5. Because here, as what you can see, as what you can observe in our graph, it starts from the positive 5 going downward. That means going to negative infinity. So therefore, our range will be the interval starting from positive 5 until negative infinity. Let's have this example. Given the function f of x is equal to the square root of 3x minus 4, this is an example of a square root function. Now, always remember the restriction when we have the square root function. In square root function, we cannot take any values of x that will make our radicand negative. Make sure that that value will result to positive radicand. But how can we identify the domain of this given function? So to determine the domain of this given function, we will take the radicand 3x minus 4, that is 3x minus 4, and then we will take that one into inequality which is greater than or equal to 0. And then we will solve for the variable x. So we have 3x is greater than or equal to positive 4. Divide both sides by positive 3. That will be x greater than or equal to 4/3. That means our domain will start from positive 4/3 until positive infinity because this is greater than or equal to 4/3. So that will be our domain, the interval 4/3 to positive infinity. But how about the range? Since we cannot take negative value of our radicand, therefore our range will start from 0 up to positive infinity. So how does the graph of this given function look like? So since our domain will start from 4/3 until positive infinity and our range start from 0 until positive infinity, we will take only the quadrant number 1 in our Cartesian plane. So therefore, by estimation, for example, this will be 4/3. So we will take here the 4/3 0. So our graph pointing to the right. As what you can observe, our graph is pointing to the right. That means if we are going to extend our graph to the right, that will take all the values in our positive x-axis. And then if we are going to extend our graph to the right, that will also take all the values of our positive y-axis. Let's take a look with this example. Given the function f of x is equal to 1 over x plus 3, this is an example of a reciprocal function. In reciprocal function, the restriction is we should not make our denominator into 0. So what will be the possible values of our x that we are going to substitute to it that will make the denominator into 0? So to find out the possible value, we are going to solve for x. We will take the denominator and equate the denominator into 0. So we have solve for x, that will be x plus 3, take the denominator and then equate to 0, that will be x is equal to negative 3. So the possible value of x that will make our denominator into 0 is negative 3. So that means our domain will be the union of the sets negative 3 to negative infinity and then union negative 3 to positive infinity. Or let's just simply say that we'll take all real numbers except negative 3. How about the range? To find the range of this given function, we will define the inverse function by interchanging the position of x and y. So by that, given the function y is equal to 1 over x plus 3, since y is equal to f of x, we will interchange the position of x and y. So we will make y into x. That will be x is equal to 1 over y plus 3. Then we will solve for variable y. So we have x times y plus 3 is equal to 1. Distribute x to the two terms inside the parentheses. That will be xy plus 3x equals 1. Since we are solving for the variable y, we will transpose 3x to the other side. That will be xy is equal to 1 minus 3x. Divide both sides by x. So that will result to 1 minus 3x over x. The same process in solving for the domain, we will equate our denominator into 0. So since our denominator is x, we will equate x into 0. So that means we have x is equal to 0. By that, we can define now our range, which is the union of the interval negative infinity or 0 to negative infinity, union 0 to positive infinity. Or let's just simply say that will be the set of all real number except 0.